Converse of the Pythagorean theorem. How can you test the converse of the Pythagorean theorem and use it to solve problem? We test whether the triangles whose side lengths are A, B, and C satisfy the formula A squared plus B squared equals C squared. You can use the converse of the Pythagorean theorem to help you determine whether the real-world triangles are right triangle. Example 1. Identifying the right triangle. Tell whether each triangle with the given side length is a right triangle. 9 inches, 40 inches, and 41 inches. Let A be 9, B be 40, and C be 41. C always the longest side. The formula is A squared plus B squared equals C squared. We substitute them in 9 squared plus 40 squared. We don't know if it is equal to 41 squared. So we put a question mark. 9 squared is 81. 40 squared is 1600. We put a question mark. Equals 1681. Now we add 81 to 1600. Equal 1681. On the right side is also equal 1681. Since 9 squared plus 40 squared equal 41 squares, the triangle is a right triangle by the converse of the Pythagorean theorem. Now, letter B, 8 meters, 10 meters, and 12 meters. Let A be 8, B be 10, and C be 12. We substitute them in. We write an equation, A squared plus B squared equals C squared. 8 squared plus 10 squared, we don't know if it's equal to 12 squared. We know this is 64, this is 100, and this is 144. We add 64 to 100. We got 164 on the left side. On the right side, C squared equals 144. They are not equal to each other. Since A squared plus 10 squared is different, is not equal to 12 squared, the triangle is not a right triangle by the converse of the Pythagorean theorem. Now, your turn. Tell whether each triangle with the given side length is a right triangle. Your turn. Let A be 14, B be 23, and C have to be the longest one, 25. We write an equation, A squared plus B squared equals C squared. Now we substitute in 14 squared plus 23 squared. We don't know if equal to 25 squared or not. So we do 14 squared is 196 plus 529. We put a question mark equals 625, 425 squared. We add these two together, we got 725, and the right side is 625. They are not equal to each other. So, since 14 squared plus 23 squared is different from 25 squared, the triangle is not a right triangle. Now, number 3. Let A be 16, B be 30, and C, again, C is the longest side, 34. We rewrite the Pythagorean theorem, A squared equals A squared plus B squared equals C squared. We substitute 16 squared plus 30 squared. We don't know if it's equal to 34 squared. Now, 16 squared equals 256 plus 30 square is 900. We put a question mark, and then 34 square equal 1156. We add these two together. We got on the left side is also 1156, and the right side also the same thing. We put equal sign. If it's equal, it satisfies the Pythagorean theorem. So we make a conclusion. Since 16 square plus 30 square equal 34 square, therefore the triangle is a right triangle. Now, on the back, real world problem. Using the converse of the Pythagorean theorem, Kay is buying agent for triangular flower garden she plans to build in her backyard. If the length of the 3 pieces of agent that she purchases are 13 feet, 10 feet, and 7 feet, will the flower garden be in shape of a right triangle? Now, we use the converse of the Pythagorean theorem. Remember to use the longest length for C. Okay, A is 7, B is 10, and C is 13. We write the formula A squared plus B squared equals C squared. We substitute 7 squared plus 10 squared, put a question mark to compare with C squared. 49, 100, and this is 169. We add these two together, we got 149. 149 is not equal to 169. Since 7 squared plus 10 squared is not equal to 13 squared, the garden will not be in shape of the right triangle. Now your turn, number 6. A blueprint for the new triangle playground shows that the size measure 480 feet, 140 feet, and 500 feet. Is the playground in the shape of a right triangle? Explain. Okay, first, let A be 480 feet, B is 140, and C, of course, the biggest one, 500 feet. Now, we write an equation, A squared plus B squared equals C squared. We substitute to see if A squared plus 140 squared, we don't know if it's equal to 500 squared. So, we work it out. This number, 480 squared, is 230,400 plus 19,600. We put a question mark. And on the right side, C squared, we got 250,000. We don't know yet, so we're going to add these two. On the left side, when we add, we got exactly 250,000, 5,000. And then the right side is also equal to 250,000. So it satisfies A squared plus B squared equals C squared. So we make a conclusion, since A squared plus B squared equals C squared, right? The playground is in the shape of a right triangle. One more problem. A triangular piece of glass has sides that measure 18 inches, 19 and 25 inches is the piece of glass in the shape of the right triangle. Explain. So let A be 18 again. B is 19. Of course, C is the biggest one, 25 inches, the longest one. Okay? So you can put inches here or not, doesn't matter. We're going to substitute to the equation A squared plus B squared equals C squared. If 18 squared plus 19 squared, we will need to test if it's equal to 25 squared or not. We don't know. We shouldn't put the equal sign here. I'm sorry. So we put the question mark. So we do 18 squared is 324 and 361. We don't know is equal to 625. So we add them up. The left side is more than the right side. It's different from 625. So we make a conclusion. Since 18 squared plus 19 squared is not equal to 25 squared, the piece of glass is what? Not in the shape of a right triangle. Now, how can you use the converse of Pythagorean theorem to tell if a triangle is a right triangle? You need to answer that question. How can you use the converse of Pythagorean theorem to tell if a triangle is a right triangle? So, what do? We need to test, right? We test whether the side line in A squared plus B squared equals C squared. We need to test this. And then we using the longest side for C. Okay? And then if the equation is true, the triangle is a right triangle. Otherwise, it isn't. Thank you for listening.